Is Math Grade 8, Section 1.2, Part 2, the continuation of the product and the quotient of powers. We have already covered these 2 pages of notes, and today we will be continuing, starting on with section Use the quotient of powers property with algebraic expressions. This begins on page 19 of your textbooks. We are going to be using quotient of powers property to be able to simplify algebraic expressions. Let's try an example. This first example is example number 12. Let's give it a try. A. Simplify each expression. Write your answer in exponential notation. h6k squared divided by h5k. For the solution, we can write this as the first term over the second term. So it equals h6k2 over h5k. Now let's multiply this times this by separating in between this part. We're going to pull them apart. That equals h6 over h5. And then k squared over k. And we can simplify this further. This equals h6 minus 5 times k2 minus 1, which equals hk, because we're left with 1h and 1k. Let's try B. B, we have 28m7n4 divided by 7m3 and 2. In this expression, we're going to rewrite it like we did above to equal 28m7n4 divided by the second term, 7m3 and 2. Let's separate this out a little bit into our numbers. 28, 7 times our n's, m7, m3 times our n's, n4, n2. Let's move it down here. 28 divided by 7 is 4 times m7 minus 3 times n4 minus 2. This gives us in total 4 m4 n2. Go ahead and try guided practice 14 and 15. Next section, multiply and divide expressions in exponential notation. Go ahead and make sure you're keeping all notes. Let's go ahead and do example 13. Use exponent properties to simplify numerical and algebraic expressions. Similar to what we did above. Simplify this expression. 4 to the power of 2, 4 to the power of 7, 4, 4 to the power of 3, 4, 4 to the power of 4. Okay, instead of doing 2 minus 7 and 7 minus, or 2 plus 7, and then doing again 2 plus 4, we'll just combine the whole thing. So we have all 4's on top. Let's combine those by adding 2 plus 7 plus 1. Remember, if there's nothing written here, it's an assumed 1. On the bottom, 4, 3 plus 1, there's the assumed 1, plus 4. That equals 410 over 4 to the power of 8. From this, when we're dividing, we know we can subtract, so now it would be 410 minus 8, which gives us 4 squared. Let's try this with a second example. This one's involving fraction 1/4. So we have 1/4 cubed times 1/4 times 1/4 squared over 1/4 times 1/4 times 1/4. Let's simplify the tops like we did up here. 1/4, 3 plus assumed 1 plus 2 over 1/4, 1 plus 1 plus 1. Okay, which makes sense because 1 plus 1 plus 1 equals 1/4 to the power of 3 means you're multiplying 1/4 times itself 3 times, and that is exactly what we're doing down here. The top is similar. 1/4, 6. We are multiplying 1/4 times itself 6 times. Now let's simplify again. 1/4, 6 minus 3 equals 1/4 cubed. And that is our answer for this one. Turn to the next page. Example C. Example 13, problem C. 3x4 times 5y5 times 6x6. On the bottom, 2y times 3x squared times 5y cubed. Okay, we are going to go ahead and put together like terms. We are regrouping. So take each of the numbers in your problem, each of these base numbers here. It's going to be 3 times 5 times 6. Draw a long line. On the bottom, you do the same thing. 2 times 3 times 5. Now we have x's, so you want the x's to go together. x4 and x2. We want the y's to go together. And we have more x's on the top. Almost missed that one. x6 on the top. So we have these 3 x's. Then we have y, y, and y. On the top, let's multiply y5. The bottom, we have y times y3. I wrote it with the space here so you could see that these x's go together, the y's go together, and the numbers go together. Okay, let us put these together. So 3 times 5 times 6 is 90. For the x's, we have x4 plus 6. For y's, it is just y to the power of 5. On the bottom, 2 times 3 times 5 is 30. And our x, we only have 1, so it's still x squared. And for our y's, we have y, 1 plus 3. Whoops, 1. Remember, the 1 is assumed here. Now we are going to further simplify this. I'm going to move this down here. It's equal to 3, because 90 divided by 30, we can simplify that expression to be 3 on the top. We have 3 on the top, x10, y5. The bottom becomes x2, y4. Because 30 was gotten rid of when we did 90 divided by 30, which is 3 on the top. You have an assumed 1 on the bottom, but it's not needed to write there. Okay, now this is equal to, make sure you can see it. This we are going to simplify. It is 3, and we can do x10 minus x2. And our y's, y5 minus 4. 5 minus 4, 2 minus 2 equals 3x8y. And we went from this giant complicated problem to this problem, and they are equivalent. Go ahead and do guided practices 16, 17, and 18. Moving on to example 14. Solve a real-world problem with exponential notation. This is very exciting. It's science. Water molecules. This is what a water molecule looks like. We have 1 oxygen and 2 hydrogens. hence H2, because there are two H's. O, this is H2O. There are approximately 10 to the power of 25 water molecules of these in just 1 liter of water. Patrick has 100 liters of water. This L, by the way, is standing for liters. How many molecules are there in all? Write your answer in exponential notation. To solve, we're going to start with the number of molecules in 1, we can write a 1 here, in 1 liter of water. And we're going to take that times 100 liters because we need to get 100 liters. So you're going to write number molecules in 1 liter. We're going to multiply that times number of liters that we have. This is 10 to the 25th power times 100. We are going to substitute values. 100 is also equal, we're going to keep this 1025, but 100 itself is 10 to the power of 2, because you could also say it's 10 times 10. The base number is 10, multiplied by itself twice, the power is 2. Just as in 25, there would be 25 zeros, the power of 2, there are 2 zeros. And this would be a very long number. We'll write it out for you. Next, we just simplify. 10 to the power of 25 minus 2 equals, or plus 2, I'm sorry, it's multiplication. 10 to the power of 27. Do guided practice on your own, the challenging ones, about the planets. Guided practice 19, and that is all for notes today. We will see you in class tomorrow.